This video will cover mole to volume conversions. In each of these problems, we'll be given values in moles, and we'll be expected to convert these values to liters. If you look at each of the chemical substances in problems 1 through 4, you'll notice that these are all covalent compounds, and the state of matter they exist in for these specific problems are gases. These gases are said to be at standard temperature and pressure. So these conditions we'll talk about later when we get to gas laws, but for our purposes, you can say that standard temperature would be 0 Kelvin and 1 atmosphere of pressure. Before we begin these problems, let's take a look at the mole map to make sure we understand the units that we'll be using to solve these problems. So, since our given values for these problems are in moles, we'll still be using 1 mole. And at STP, at those standard conditions, any gas at that temperature occupies 22.4 liters of space. So when we're converting from moles to liters, we're going in this direction. Let's start with problem number 1 as our first example. So we'll begin by writing down our given value, which is 1 mole of water. We'll be solving each of these problems using dimensional analysis. So let's set up our dimensional analysis table. Since we're given moles to start with, we know that that is the unit that we need to cancel out. So we're going to put moles in our denominator of our setup. And because we're being asked to convert to liters, that is the label that we'll put in our numerator. The conversion factor would be 1 mole equals 22.4 liters. So we don't really need a calculator to do this math. It's quite simple, right? 1 times 22.4 is 22.4 divided by 1. It's the same thing. So just know to cancel out your labels, moles of water and moles of water cancel. You multiply across. We need 3 significant digits in our final answer because we're given 3 to start with. So 1.00 times 22.4 is simply 22.4 liters of water. Let's look at number 3 as our second example. 1.75 moles of carbon dioxide is our given value. We want to cancel out moles of carbon dioxide, so we'll put that in the denominator of our conversion factor. And since we're converting this to liters, we put liters up at the top, the numerator. Okay, the conversion factor is 1 mole equals 22.4 liters. Remember to cancel out your units and then multiply the top and divide by the bottom. So let's get our calculators out so we can do that. 1.75 times 22.4 equals 39.2. We have 3 digits in our given value here, so we can stick with 3 digits in our final answer. 39.2 liters of CO2. That's our final answer. In problems 5 through 8, we're going to be looking at the opposite. This time we're converting from liters of gas to moles of gas. And again, the conditions that were... And again, these gases are said to be under STP, standard temperature and pressure. Let's take a closer look at our mole map to make sure we understand which way. Let's take a close. Looking at our mole map, remember that it's always 1 mole here. And because we're talking about a gas at standard temperature and pressure, at those conditions, of 1 mole of any gas occupies the volume of 22.4 liters. For this set of problems, we're starting at liters and we're converting to moles. So we'll be going in this direction. In problem number 5, we're given 5.0 liters of hydrogen gas. Remember, hydrogen is a diatomic molecule. In problem number 5, we're given 5.0 liters of hydrogen gas, so that's why we write that down as our given value. Next, we set up our dimensional analysis table. Liters of hydrogen will be in our denominator since that's the unit that we want to cancel. We're converting liters to moles, so moles will be in our numerator. And now we plug in the values. It's 1 mole equals 22.4 liters. Let's take out our calculators and solve. Remember to cancel your units. Liters of hydrogen and liters of hydrogen cancel. 5.0 times 1 is just 5.0. So 5.0 divided by 22.4 equals 0.2232. So we're going to round that calculator answer to 2 significant digits because that's what we're given in our value to start with. So our calculator answer will be rounded to 0.22 moles of hydrogen. Let's look at problem number 7 as our next example. 28.0 liters of nitrogen dioxide is our given value. That's our dimensional analysis table. To cancel out liters of NO2, we need to put that label in the denominator, and we're being asked to convert this to moles of NO2, so that will go at the top. The conversion factor is 1 mole of NO2 equals 22.4 liters. And now we're going to use our calculators to do the math. 28.0 times 1 is 28.0 divided by 22.4. That comes out to 1.25 moles of NO2. We can use our calculator answer because we need 3 significant digits in our final answer. And this is how you convert between liters and moles at standard temperature and pressure conditions.